Y'all. A squared plus what?
B squared.
No, what is 2 squared?
4. C squared. Oh.
Plus 4. No, it does not equal 4. No, it does not equal 8. 16. What does it mean to square a number? Multiply it by itself. That is not 4 times 2, that's 4 times 4. Alright, Jordan, I haven't called on you yet today. What do you think we should do to this equation now?
Minus 4 on both sides.
Okay? Rose, why are we subtracting by 4 on both sides? Y'all, I asked Rose a question. I can't hear her, which I know means you can't hear her. Rose, why are we subtracting both sides by 4? Okay, so I need an equivalent equation, right? But Bashar, why are we subtracting by 4? Okay, but why is this going to get a squared? What told me to subtract by 4, London? Ah, we need the inverse of what? Plus 4. So minus 4. And hey, what is 4 minus 4? 0.
Is that a 35 or a 45? What is that? Inside the triangle.
Here?
Yes.
30.
Oh, okay.
Remember this 30, 60, 90.
Okay. Not you cursed that one.
Okay, so a squared is now equal to 12. Take the square root.
It's 3.124.
No.
Yeah, that's wrong, baby. Which is wrong?
So we can leave it as square root of 12. Hey, Eileen, which is your sheet?
Oh.
So here's the thing, we could leave it square root of 12, but we're going to miss out on the pattern. Remember yesterday I walked you through how to simplify the radical? You don't have to do it on your own, but we're going to have to simplify this radical. Does anyone know a factor of 12 that you can take the square root of?
I know.
Okay. How old are you? How old are you?
21.
Yeah, it sounded like it. Okay? You're in high school. I respect the enthusiasm, but let's do it in a way that respects everyone else around us.
Like, make everybody happy.
But here's the thing. You being happy right now is also off-putting to everyone else. It's a way to find for the whole class.
All about enjoying.
Okay, but you can raise your hand respectfully and be excited without, ooh, call on me, Mr. Kinney. I'm so excited. All right. Matthew, what is a factor of 12?
6.
12. 4.
3.
2.
Okay, but I asked the question, what is a factor of 12 that I can take the square root of?
2.
6. No.
Okay. Can I take the square root of 6?
No.
Yes.
Type square root of 6 in the calculator.
No. 2.
Why are you scared? It's okay to have a hypothesis, but then you have to check it to see if it's correct. Can you take the square root of 6? No. You never checked your hypothesis.
You said yes. I said no.
Can we take the square root of 4? Yes. So I'm going to rewrite this 12 as 4 times 3. Isn't 12 4 times 3? You just told me we can take the square root of 4? Yes?
Yeah.
So remember, this is what we did yesterday. I can split up that square root into 2 different square roots.
You right.
The square root of 4 times the square root of 3. And what is the square root of 4? No. 2, dude. Here's the issue. This is why I'm frustrated. Did you even think about it, or did you just shout something?
Shout something.
That's a whole lie. I didn't even finish asking the question. 2 times what?
4.
Y'all, 2 times what?
12. Oh, 4 times 3. Oh, that's 4 and 3.
Remember, the square root of 4 became 2.
Oh,
What's still left?
3.
So times square root of
3.
3. Okay, but you are one person out of 25. Okay? I was waiting for other people to get there, Rose. So, we want to recognize that it's 2 square root of 3. Hey, really quickly, what was the ratio for our first 30, 60, 90?
12.
No, what was the short side?
1.
And then the altitude was? Y'all look at number 8. What was the altitude at number 8? The square root of 3. And then what was the hypotenuse? 2. Now here in number 9, what is the shortest side?
1. No.
2. What's the altitude?
3.
2 square root of,
3.
and then the hypotenuse is? There might be a pattern there. Let's see if that pattern still exists within number 10. So within your small groups, right, you're going to need to draw the altitude into the triangle and then use the Pythagorean theorem to find the length of the altitude of this equilateral triangle. So, if you get stuck, you're not going to sit there, you're not going to distract others, you're going to read the directions. If nobody within the group knows what you're going to do, what you're doing, put your hand up and I'll come over and check on you. Okay? I'll be coming around, let's get to work. This way so you can focus on that. That's not even the sheet we're on right now. But you're not focused. You cannot learn as well being distracted. If it was art class, I wouldn't be expecting you to do math. Okay, so in math class, you need to do math. Put the book away. At this point, it's just being disrespectful to me because if I asked you to do something, you blatantly chose not to. Yes, ma'am.
Sit your paper down.
Okay, be quick.
And read.
So what are we thinking for number 10? What are we going to do?
Work some Do some work.
She bumped you up, we heard you.
He's
I
not
don't think
pre-K.
that we've done every time up to this.
He's not a pre-K no more.
We're going to use the Pythagorean theorem, but remember, we had to have what on numbers 8?
He's saying, I'm gonna have all the snacks.
Huh?
Oh, God.
We're trying to find the
But I
altitude,
can
right?
control them.
Do you have the altitude yet? So you need to draw your altitude in. Okay? So keep that in mind. Yes, ma'am.
Hold on.
Right there.
1, 2, 3, 4, 5, 6. Correct. Right, because that altitude represents be perpendicular and split it in half, right? 1, 2, 3, 4, 5, 6. Okay. Remember, it's equilateral. Every side length is 6. Yo, are we for real? How old are we?
I need a pencil.
Like, put it away.
I'm out of late. Ain't no laying enough for you, buddy. A pencil is?
Yo, math. Let's get focused on it. I released y'all 2 to 3 minutes ago and you haven't even done a single thing yet. So what are we doing for number 10?
Use an equilateral triangle. There's 6 units on the side.
Yep, there it is.
You divide it. Split it up.
Okay, by drawing the what in there?
I don't know what y'all doing, bro.
Yo, what do we need to draw in there?
The altitude.
The altitude?
Altitude.
Looks like Gabe's already got some ideas about it. Let's see if we can follow it.
I know.
He said one.
This is where 27 is going to give you trouble.
We're gonna start smoking on your granddaddy key.
So find this factor 27 that we can what?
Because it's 30, 60, 60, 60.
Watch your language.
Stop breaking my legs. I'm trying to work.
So think about
I gotta see you got
So remember that's what you do right there. Talk.
your mama dead.
You're not even looking at the right sheet of paper, but right side of the paper. Nah, dude. You could ask a question about that in the whole class. It's not gonna be 100%. Number 10. How are you gonna start this? Well, because you're missing something right now. Look at all these triangles. What are you missing that these triangles have?
No, she ain't the big. Y'all, yeah, you try to she ain't the She said
You already have the sides.
you
Look.
No, great.
She not dead.
3, 4, 5, 6.
On God, she not dead. Stupid.
Right?
No, she not dead. Dummy. Because I seen it.
Oh, she like 130?
No, 102.
How about you look at the directions? The altitude. You will need to draw the altitude. You follow the direction. You know the altitude is from a vertex perpendicular to the side of the rock.
Granddad lives 130.
That was right there. Yep. Yeah.
The nigga went to the kitchen to get some juice.
Use that altitude. No, we didn't. So then look and drop down to the bottom. That's 30.
I ain't need that type of person.
How long is this?
It's okay, my auntie.
I lie about that.
It's okay, my auntie.
It's not the dots. 1, 2, 3.
And my auntie, I'm not very, my auntie got a house science, but I went like, I was born with like,
Rose,
she
what
got
group you
a
in?
house. They burned her ass up.
That's 6. Draw it.
Everybody.
What's the other side? What's this side down here? I'll find out. Yes, sir. I'm coming. Hey, there's no need to put him down, Bashar. That's not helpful to him or to you. You already started to.
I really have an taste in the heart attack.
How long is that
That
side?
heart wasn't working correctly. That little phone working correctly.
I mean,
Because they told you it was 60
How you
units.
get your little heart?
How long is this side?
she get a new heart.
Okay.
Get new lows. Exactly. It don't make sense. Dude.
You have 2 sides of a right triangle. Oh, okay.
Get new lows. You got average.
Well, you're talking about this body.
Okay, you can take somebody else. They must somebody put in your body.
60, 90. But we're not on the sides now. Now, you already said you looked at his pretty tall, so you're gonna figure out what's going on.
My brother makes me so my brother like
Yeah, I'm about to ask you which side has it. I'm about to ask you which side has it.
Look at it, you can count it. Thank you. Thank you. Thank you. Thank you. We're about to talk through that. For those of us who have been working diligently, most of us already have at least most of this problem started. Now let's go over it. So, you got to follow the directions. Remember, we need a 30, 60, 90 degree triangle. Do I even have that yet?
No.
No. So what do I got to draw in?
The
I
line.
got to split it in half, drawing in the altitude. Thank you. Because that altitude is what to the side opposite? Perpendicular. And so notice, what is this length over here, the hypotenuse? 6. This short side is 3. And so now I can use my Pythagorean theorem. A lot of us were being very successful, especially getting up to this point. Notice that's Pythagorean theorem. Does anyone have a question about that Pythagorean theorem? Brandon, you good with it? Yeah. Okay. So now what am I going to do? Guys, Gabe's not going to help me figure this out. You need to look up here. 3 squared is? 9. Okay. Subtract 9 on both sides. Quick question, is anybody else distracted by Brandon and Bashar talking?
Yes.
No, I am not.
Yes.
I am.
Okay.
wow.
Then when I ask, do you understand this equation, you should have asked a question to the whole group. The small group time is over. It's time for a whole class discussion.
For real. No, you don't.
So, a squared is equal to 27. Now take the square root.
We taking square root of what? Oh, yeah.
Because the square root of a square is the inverse. It
Where did it come with all these words at? Square root. Where did it come from?
A equals.
right. Well, the square root and the square they cancel. Thank you. A is equal to the square root of 27. And some of us already got here, but Kelsey, you're like, I don't know where to get the factors, right?
That's all. Gabe asked for
You found the factor of 3? Okay, 3 times what gives me 27?
21. Oh, wait.
3 times 9.
7.
I thought it was 3 times
3 times 9? Hey, can I take the square root of either of those numbers?
What is it, 7?
No.
Oh, no.
Nine.
I can take the square root of 9, can't I? Okay, so we need a factor that we can take the square root of. Okay, that's the 9. And so, remember, I'm going to split up my square root here. Square root of 9 times the square root of 3. What does A equal? 3. That square root of 9 becomes 3 times the square root of 3.
Go to the square root, A equals, then we got square root again. So you put it in the
Say again.
I got my square root from 103.
Well, remember the square root of 9 times 3, that was the 27. I can't take the square root of 27, which is why I had to factor it, and then I could take the square root of 9. But then I can't take the square root of 3. Well, the good news for you is, Kelsey, the only times you're going to have to do the square root is right now because simplifying square root because I'm walking you through it. There should be a pattern just like with the 45, 45, 90. We're trying to find that pattern. So, now, hold on.
So that means both of y'all supposed to be. We should be crying too, Sean.
Y'all, up here. So when the length of the short leg, right, that was number 7, I think, or number 8. When the length of the short leg, which was half of the triangle side, was 1, what was the length of the long leg, the altitude? The square root of 3. And what was the length of the hypotenuse, the side of the whole triangle? 2. And then, when the length of the short leg, half of the triangle, was 2, the length of the long leg was length of the long leg. That was our altitude. 2 times the square root of 3. And then what was the length of the hypotenuse? 4. So don't forget, by the way, just clarification on language. Remember, the legs are the sides that are not the hypotenuse. The legs are the sides that are not the hypotenuse. And so now we just looked at when the side length was 3. When the side length was 3, what was the length of the long leg? 3 times the square root of 3. Matthew, focus. And then what was the length of the hypotenuse? 6. So, why don't you work within your small groups to try to figure out what each of these side lengths would then be based on knowing what the short leg is of the 30, 60, 90.
I got it, guys.
Let's get to work. Use the patterns that you see. Yes, ma'am.
2, 4, 6, 8, 12.
Huh? Where? No, I didn't. That's plural. Formula. It's a whole group. I promise you, if I wrote it up there, I knew. No, I need to use Well, remember, if it is generalized, it's just generalized. So, what have you done to the short side every time? Buddy, don't give me those. Stop counting the points. It is the lengths. How many lengths is that? Yeah, how many lengths is that? That's one, right? This one is. And then we have
We're trying to work with Kasha, but Kasha goes.
I need
Then, if he's going to sleep, let him sleep. You worry about yourself.
I got 117. He wasn't even talking about you. What?
Is he getting all upset or something?
No, he just woke up.
Sir,
Oh, hell no. Come here.
no. I'm teaching.
Come on.
Thank you. Thank you. Thank you. All right. So, Terrian, if the short leg is 4, what's the length of the long leg?
You said what?
Times what? Times square root of 3, okay. Jalen, if the short leg is 4, what's the length of the hypotenuse?
I put 8.
8. Alright, Gabe, if the short leg is 5, what's the length of the long leg?
5 times square root of 3.
5 times square root of 3. Rose, what is the length of the hypotenuse? Matthew, if the short leg is 6, what's the length of the long leg?
6 times square root of 3, and then it's going to be.
No. You had your chance. Let me get somebody else in there. Jordan, what's the length of the hypotenuse? 12. Dee, if the length of the short leg is 7,
7
What's-
times the root of 3.
7 times square root of 3?
Yep.
I gotta ask, is there a pattern here?
Yeah, they're going by 2, 4, 6, 8, 12.
What?
Well,
I'm just talking about within each
Oh,
piece here.
yes, because they got 3.
So if I multiply by the square root of 3, that's how I get to here?
No.
The outside number would be
They going
No, I'm talking about to get the length of the long leg,
They
we're
going
multiplying by the
numbers
square root
at the
of...
top. They going by numbers at the top.
No, yes, but what am I doing to the 7 to get this number?
You square.
Multiply by 2. My bad.
Multiplying by what, Rose? The square root of 3,
Exactly.
which I think is what Ari was saying. Now, to get the hypotenuse, what am I doing, Gabe?
Multiply by 2.
Multiply by 2.
Okay.
Is that a pattern that's held up all the way through?
Yeah.
Yes? So then this would be 8 square root of 3 and 16. But then I get to this x here. Claire, what would the length of the long leg be for x?
X times the square root of 3.
X times the square root of 3. Alright? Dee, I've already had you. I'm going to get Bashar.
Okay.
Let's think about it.
We don't know.
You don't know?
What
Have you paid attention or written any of this down as we've gone over it?
No.
So, you haven't seen this pattern. Y'all, put your hands down. I'm talking to Bashar right now. Bashar, you haven't seen a single pattern about how to go from the short leg to the hypotenuse?
Where's from the other page?
6 to 12, 7 to 14, 8 to 16. There's no pattern there? What's the pattern? Oh, so if it's x, what am I going to do to it? Oh, multiply by 2. How would I write x times 2?
That's times 2.
Usually we write that as 2x. Right? So, what we want to recognize then, if we have a 30, 60, 90 degree triangle, what is the general length of the side opposite the 30 degree angle?
60.
30.
I think you're talking about an angle measure. I asked about a side length. So like if this is 30 here, what is the general side? Notice what's opposite the 30. Is that my short side, my long side, or my hypotenuse?
Short.
What was the length of the short side in general? No, what is the length of the short side in general? Yo, look at the table. What is a general term or expression for the short side? When I say general, that means it could stand for any length. Wasn't the x my short side?
Yes.
Yes.
So then the side opposite 30 degrees we're saying is x.
Well, no, you have to see that double program.
Sure. I worry about my classroom. So then 60 degrees, remember, would be here. And the side opposite is my altitude or the long side, long leg. So what would the side length here be? What was the general length of the long leg? We said short leg was x.
X times the
One.
square root.
Didn't we say to get to the long leg, we were multiplying by the square root of 3 every time?
Yes. Oh, snap, that's crazy.
We gotta write that out.
And then what is the length of the side opposite the right angle? Remember, that's also known as my hypotenuse.
2x.
Wasn't it 2x?
Wait. I don't know.
So the side opposite 30 degrees is x. The side opposite 60 degrees is x times the square root of 3. And the side opposite the 90 degrees is 2x. We're going to use this to solve triangles. But I also want to point out, we can use this to find trig ratios. Because remember, does it matter how big the triangle is? No, the ratio is always going to be the same. So I want you to notice, here's 60 degrees, right?
Right.
If I want the sine of 60 degrees, how do I calculate sine?
Opposite of 60 degrees.
Side opposite, 60
Side
degrees,
60 degrees.
divided by?
Hypotenuse.
How about a
Okay, so then notice that means that the sine of 60 degrees, what's the side opposite 60 degrees?
I can use x times the.
Notice that's the x square root of 3. By the way, if I were you, I would have drawn this triangle. Maybe I'd draw it bigger, but I would have drawn this triangle on there
That's a side op.
along with this extended ratio.
Okay. Actually, when I add 11.
Okay, so what is the length of the hypotenuse?
6. Oh, my bad. I'm sorry.
I take that
2x.
Yeah.
Do any of those factors cancel? X squared root of 3 divided by 2x.
No.
We don't know what x divided by x is?
1.
Anything divided by itself is
1.
1.
Oh. Yeah.
So I want you to notice the sine of 60 degrees is and always will be, what am I left with in the numerator?
Square 3.
Square root of 3. What am I left with in the denominator?
2.
So if you know this generalized ratio, you can always find the trig ratios for a 30, 60, 90.
Right.
Right?
Yes, right.
You right.
Right.
When he gets back. By the way, this might help. I do want you, just because this will help you in the future, I believe. Look at the 45, 45, 90.
What we at?
Really quickly, that was the previous sheet.
What 45, 90?
That was the previous sheet. Number 6 here, where it says, what is the general ratio? I believe a lot of us already put for 45, 45, 90. It's x, and then
X.
x, and then,
X times the square root.
and so what I would do is I would also draw the triangle here to help you. So 45, 45, 90. So it would be x, x, x square root of 2. So I would draw that triangle along with this ratio on the 45, 45, 90 to help you in the future.
Not the next
Okay?
I'll have to look at it.
Don't worry. Alright. I guess you could have technically put the x squared and 3 and 2x on it, but don't sweat it. Alright. So we should all have this sheet of paper, the special right triangles practice, on our desk. I passed it out while you were working on the last little section.
I ain't get it.
I put it out there, it's there somewhere.
Oh, is this one?
Yep. So, here's what I want us to recognize. We've actually looked at this pretty heavily. When it comes to the special right triangles practice, there's two different ways to approach it. First off, could I just draw my 45, 45, 90 to help me figure out what to do? Okay, so 45, 45, and 90. So what is the general 45, 45, 90? This side would be?
I don't even see that.
X.
X. Yeah.
Square.
Wait, hold on.
2.
X
Two.
square root of
What,
2.
x squared to 2?
Yeah.
Yes.
Matthew, you're blindly staring at this when you should have notes on your paper.
I thought it was 2.
It is.
Okay.
Okay?
So is it always gonna be 2?
Smart, okay.
Say again.
Is it always gonna be X square root of 2?
Isn't that what we saw in the 45, 45, 90 yesterday?
Oh,
Yeah, uh-huh. Okay, so I want us to notice here. Listen. Listen, listen, listen. Even though these triangles are different sizes, we know what about those triangles? They are,
Similar.
say it again,
Similar.
they're similar, right?
Figures.
Which means they have the same
Size.
ratios. They have the same ratios. Notice how we have this side length here. That's 8, right? So 8 to x would equal what ratio based on this triangle? What would be the ratio based on this triangle? Notice where does this 8 show up in this triangle?
At the top. Oh, at the bottom.
At the bottom, right?
Jason.
Notice that's the side opposite a 45-degree angle.
Yeah.
Divided by,
You supposed to write
what would I put?
8.
Remember the 8's from here. Notice the 8 and the x go together. What is this x for that triangle though?
We don't know.
But what is the side called?
8.
Oh.
Say it again, Matthew.
Hypotenuse.
That's the hypotenuse, isn't it?
Yes.
Do we know what the hypotenuse is for this generalized triangle?
No.
No.
Yes, it's X times.
Okay?
Oh gosh, I wasn't amazing.
Okay? So, now what I will point out here is, I would not leave those x's there, and I honestly, this is known as the generalized ratio, but instead of doing x squared, x, and x squared to 2, oftentimes I just do 1, 1, and 1 squared to 2. That's going to help me significantly, but you choose which one you want to do. The reason why I might not want to do x is because this x, not necessarily the same as that x. Okay?
Wait.
Notice what, well, that's what I'm saying is one of the ways to approach this is to draw out that triangle to help you figure out the ratios to solve for the unknown sides. By the way, what is x divided by x?
1.
1, right?
Oh.
Okay. So notice this is 8